Hey everyone, this is Greg. How are you today? It's first day back to school after spring break, and for those of you that are teachers, you know that it's a rough one, but we got through the day, and it's getting a little warmer in Oregon. So I just wanted to talk a little bit about the sampling assignment and some of the things that you want to think about in sampling as you move forward in your program. Now. Uh, First of all, convenience samples and cluster samples are inferior to random samples. So let me explain why. So let's say we are studying 8th graders in the state of Wisconsin, and we want to know if a certain type of reading program has an effect on their reading scores. Okay? And if we want to generalized to the entire state of Wisconsin, then what we have to do is have a random sample, 50 or so, from the entire state of Wisconsin. So we would have to have a way through systemic sampling or some manner to get 50 random 8th graders in the state. Now, that's unlikely, okay? And so what we would have to do then is we would have to get a cluster sample, which would mean get 50 8th graders from Milwaukee County, or a convenience sample, which is just have 50 8th graders that were close by that wanted to participate volunteer their test scores. But there's a problem with this. When you use a convenience or a cluster sample, you are reducing what's called the external validity of your results. So if you are to find that those that have taken a certain reading program, a higher proportion of them pass the state reading assessment than those who have not, your results can't be generalized to all 8th graders in the state if you've only used a cluster sample of students from Milwaukee. And when you write a dissertation, if your sample is not representative of the entire population of study, you'll discuss this in a section of your dissertation called limitations, in which you'll say our sample was not completely representative of the population, so it makes the results suspect. Now, this happens in educational research all the time. People use classrooms for samples, they use schools for samples, but quite often they don't get a truly random sample of the entire target population, even though this is your goal. So you never want to choose a segmented, or you never want to choose a cluster sample or a sample of convenience if you have to. That would be equivalent to trying to figure out, to conduct a poll to see who's going to be the next president of the United States, and only asking people in Berkeley, California, or only asking people in northern Idaho. It's just that simple. The results are not going to represent, they're not going to be valid. So as you go on into your program, you're going to have to sample, with a survey or numerically. And so a random sample is always better. The other issue is sample size. Now, you will often hear the word power used in statistics, and the reason why I didn't ask you to download that power program is because power is a rarely, I don't mean to say rarely, but it's not a very well understood statistical concept. So let me try and explain what power is to you. Let's say we believe, or it's commonly thought, that the mean length of alligators in Florida is 7 feet. I don't know. I lived in Florida for a while, only saw one gator. But, so there's your null hypothesis, is that the mean length of the alligators in Florida is 7 feet. Now, you're a researcher, and so researchers look at the alternative hypothesis. For some reason, you believe that the mean length of alligators in Florida is not 7 feet, either greater than or less than. So we talked about this. Your alternative hypothesis, which is non-directional, is that the mean length of Florida alligators is not 7 feet. So you gather a sample. You get 25 alligators and you measure their length. And with that, you get a sample mean and a sample standard deviation. Now, if you'll be computing, when you get into this a little later, you'll be computing what's called a test statistic. Okay? And so if your sample of alligators, if your sample mean is a lot different than 7, then you have a very good chance of rejecting your null hypothesis, which that the mean length of alligators is 7. Where power comes in is if you have a difference in your sample alligator mean and your hypothesized mean of, let's say, 2 feet. So your sample of alligators has a mean of 9 feet. Depending upon the test statistic, you can probably reject the null hypothesis in favor of the alternative at a low risk of committing a type 1 error. Now, if your sample is larger, then you're increasing what you call the power of a statistical test. And let me tell you, a lot of people will try and explain power to you, and it's really, quite often, it's not very good. The larger the sample, the larger of the more power your statistical test has, for the following reason. The larger the sample, the less the difference in the sample mean and the population hypothesized mean have to be for you to reject your null hypothesis, simply because your sample is a better representation of the population than a smaller sample. So that's all power means. Power means you've got a greater chance of rejecting the null hypothesis with a larger sample. So let's put that power issue there. And the other thing that I wanted to talk to you about was a couple people emailed, and they were talking about SPSS and how to find certain things. So Alpert emailed me today, and he wanted to know how to find the mode with a set of data in SPSS. If you just Google these things, there's all kinds of resources on how to use SPSS. And you can really learn a lot about statistics just by Googling some of these concepts now and reading them and studying them. And you'll even come up with a bunch of my videos are up there. I've probably done 50 or 60 of them over the years on various topics. But anyway, so I want you to be clear on sampling as we go forward and you go further towards your dissertation. Now, this week we're focusing on using that SPSS. And it's important that it runs and that you stay closely connected with the week. There's an activity called the central limit theorem. Let me explain to you what the central limit theorem is. If I take a population, let me draw you a picture here. So let's say I take the population of alligators in the state of Florida. Okay? And the mode is 7. The mode of the alligators is 7. The median is 8. And the mean is 9. Okay? So here's the size, and here's the frequency. So this is the distribution of the lengths of alligators in Florida. You have a mode of 7, a median of 8, and a mean of 9. And, of course, this distribution is skewed to the right. It's a rightward skewed distribution. The central limit theorem tells us that if we take all possible samples of a given size, the mean of all sample means will be equal to the population mean. And the distribution of samples, sample means, is called the standard error. So you're going to do a little activity to work on the central limit theorem. And it's important to understanding inferential statistics. Now, again, a lot of people don't completely get it. Don't worry too much about it. But just do the activity. It'll shed some light on it. So it's been a good week. We got another one coming, and everybody have a wonderful day. Thanks. Bye.